Hello, everyone. My name is Asimgul Sulamanova. My teammate Yuta Huan. This is our final report and video recording. So our project title is Useful App for Healthy Eaters. Later you understand why. So our motivation was to create a useful app that allows user to input, for example, ingredient that they have, for example, in the refrigerator, and get all the recipes containing this ingredient. So basically, for example, if you have a banana, you just can type a banana and it gives a bunch of recipes, like for example, banana pie and etc. So which can be very useful. Also, it has a total amount of calorie for that recipe. And also we wanted for healthy eaters, if they would like to know for example, how much calories has this particular ingredient, particular item, for example, like apple, banana, dates, or peach, or maybe so they can just type it and get all the calories in different metrics. So this is basically our final report. This is like our motivation, our workflow, what library we use, how what app, what we use Streamlit for our application. This is our data set that we used from Kaggle.com, data cleaning process, Streamlit, Firebase file structure, Streamlits, features, and etc. So and also it has a learning experience that we learned from the project, challenges we encountered, and the distribution of work. So let me show our data sets. First data set is from Google.com. It has 2 million rows, 2 million recipes from all over the world. And it's kind of big, and we cut it for to make it faster, to process it faster, because 2 million recipes is too much. And also as a second data set, it's just a calorie for one particular ingredients. It has like more than 2,000 rows, and this is like in calorie range and most commonly used products. So let me start from the data cleaning first. It took a lot of amount of our time. So basically we took 2 data set, and one we cut it for our convenience for 10,000 rows, but we can increase the time whenever we want. So just for now we used 10,000 rows. So basically we wanted these 2 data sets. So we, based on the most commonly used products in calorie tab, we wanted to clean our second data set that has initially had 2 million rows, because it has recipes from all over the world. It contains a lot of ingredients that commonly rarely used. You can't find in just refrigerator in every day. So we decided to clean our data set based on the first data set. So what we did, we handled so for example, if this particular food name not appeared in the NER, it's just a list of ingredients in the recipes, for example, like brick oven pizza dough. So if it doesn't appear here, doesn't contain this list doesn't contain the product food name, so it basically cut the rows. So in order to do that, we handled plural form, uppercase, lowercase, and we just here cut it the indexes that doesn't have this item. So this is our already cleaned data set. You see, it's pretty clean. It's like have a common products, and from 10,000 rows, only 624 rows left. So, and also we wanted, because we wanted the calorie range, and as you see, this data set doesn't have, we added one more column, total calorie range, and we got the total calorie range using API calls to calorieninjas.com. So basically this is code, and this is our final data set that will be used further. So this is calories for this for each recipes that we have in our data set. So let me show our Firebase structure. So basically we have data node and name node. Name node, it's like our metadata. It has a file structure. It has all the partition location for in our data node. We have a calorie data set that's saved into five partitions, and the food data set that's saved into partitions, and name node shows the location of this partition. So just for now, I would like to show some commands, some Python codes, but later I will show every comments that we created for our EDFS in our application. So let me show our code. This is just code I will run in terminal to show some codes that we created, comments that we created for our EDFS. This is our final code that uses Streamlit. It's much longer. It's used Streamlit. So I will show it later. So for example, let's start from put command here. So this is just a put command that will get them take file, save it in equal size partition. For example, if partition number 3, input 3, it will save in 3 partitions, same size partitions. So, and this is like saved it in data node, and we created for loop. And also when it's saved in data node, it gets partition P. So it's just for example, we have P3, yeah, P2, it's P1 will be P1 and P2, and it saves it. So it's basically saves in name node, and the partition location, partition link. So this is a remove directory. So we used request and Firebase admin library for in order to utilize all the commands. Let me this is like get partition location. Yeah, so basically we here connect our database using Firebase. So here we're getting length. First of all, so for example, our food or saved in 2 partitions, so car will be 2, and then it's basically just loops for in range of car, so P1 and P2. So it gets names location for P1 and P2. I will show you in a minute. So let's start. So let me show you in our terminal. For example, this is terminal. So this is my this is like first comment I want to use, not put. Let's do remove put. I have a chunk CSV on my local computer. I want to upload to my Firebase. So I just hit enter. So I saved it into 3 partitions. It's user input. You see this data node saved it's saved in data node in 3 partitions. And it has also 3 partitions locations in name node. Cool. So if, for example, I want to know their location, get block location of this partition later on, I just this is a comment. It's just gets a chunk CSV as an input from the user. I mean file name. So I hit enter. And this is partition locations that I saved showed you earlier. And yeah, we can remove it. Just where remove. Yeah, remove, and just we can remove it unnecessary. So see, this is command automatically removes from data node and name node. So our name node will be up to date. I mean, will automatically updates every time. This is it from me now, and now Yutao explain you about the MapReduce part and also Streamlit application. Thank you very much. Just stop sharing.
Okay. Hello. I will be in charge of explain the MapReduce part and also the Streamlit the UI interfaces. And we implemented partition-based map and reduce on the data stored on the EDFS. We first tried to use Spark, but it's complex and hard to understand. So we implemented the MapReduce part using the concept taught in the class. And with our understanding, we wrote two map and to reduce partition functions to deal with our two functions. The name node knows partition locations for every file stored in EDFS. So when the map partition function is called, it takes user input and searches the input in every partition and produces the result for every partition. After that, the reduce partition is called, which combines the results from each partition and gives the final result. For example, our map function checks every partition if the data satisfy the user's requirement. If yes, we take out the list of tuples containing recipe's name and found recipe and also count one. The found recipe and count one will be in the dictionary form. And we will put them into a new list for further reduce options. When it comes to reduce part, it takes a result list from each partition and combines them together. We did not show it here, but we showed in the Streamlit. We will then put all the count one together and get a tuple with found recipe followed by a tuple of many ones. Finally, it will sums up those ones. It is a number of recipes satisfying users' requirements. So let's move to our UI interface. We use Streamlit to realize it. And on our web application, you can see the title of it and some explanations here. And we do the dataset example first. We showed our two datasets. The first one is food. And we can see here, like every element here. And yes, we got the ingredients, the directions, the title, and total calories. And we also have a calorie data set. There is calories in different measurements and also food name. So we can give users an idea of how our data set looks like, so that our users can later like play with our data set and use our functions with a better understanding. And we then use a select box to implement our commands. Although like we are just group of two, we do not want to simply just show the functions. So we refine our code to show the commands here so that our user can play with our data set. And I will show you one by one. Like the first one is ls, and we got several instructions here. Try to explore our data structure. And we also have the example, which can be type user/ascend to explore what is inside. So we just follow the instructions here. And we'll see that the children directory, which is calorie and food. If we go back to our data set, that takes some time. Yeah, and we'll see that under ascend there is really calorie and food, which means it is successful. And let's do cat. Cat is like presents the content of files. So if we try user assign food.csv, yeah, and we will get food.csv into partitions. The first one is the first 312, and the next 312 ones. Because it is like a lot of data here, so it shows in this form, like allow our user to click on everything to see the more detailed part there. And then put. And I think Sam has showed a lot of put there, and we just like make it to be present, which can be used by users to adding their wanted files. And if you want to try it, you can also follow the instruction and try your files on your own. But since Sam has done the instructions before, I will not show it here. So we switch to mkdir. Mkdir helps to create new folder. So we can do like maybe user Jessica, and it is not there before, but when I press enter, yeah, we got Jessica here. And if you want to remove something, maybe you want to remove the Jessica folder, or you want to remove a file, you're just typing, like for example, Jessica. And now it's gone. As to get partition locations, we want to know where the partitions are stored. Like for example, we type in food.csv, and it will show me the path of 2 partitions. If we change to calories, and all of these 5 paths will be shown from calorie 1 to 5. And the last one is read partition. We can read like interesting partitions. Maybe you want to see everything from food CSV partition 1, and you will get this 312 data. And if you want to know partition 2, you will get different results, like it is different. And we also modified our code to deal with like unwanted conditions, like empty conditions or wrong typing. Like if we have ls here and we do not type in anything, there will be showing waiting for your input. If we just like type some random characters here, which simply is not a file or a path, it will show no such file directory. And also, like if we want to remove something that is not existed, it will also show that follow the specifications above, check the path to the file if it exists, which helps our users to know what to input and tell them the error when they did not do the right operations, so that our application will not collapse. So let's move on to the functions. We established 3 functions. The first 2, the function 1 and 2, are related to partition-based map reduce. The first function takes in user input of ingredient names and searches all partitions ingredients. Let's see if we re-enter it. And we got map process here. We got 1 recipe containing dir in partition 1 and got several of them in partition 2. That is the map process, and we got some kind of explanation here to make our users get better understanding. And the reduce process. If the user input is in the recipes ingredient list, we take the recipe names and found recipe count 1 dictionary out to form a new list. We then combine lists from different partitions and calculate the number of recipes containing the ingredient entered by users. So now we will get, there are 6 recipes containing 0. And the second one is a little bit different from the first one. The first one, we ask user to type in something, but the second one, we just allow user to like move the range and play with it to see how many of them. Now here is like 104 in this range. And if we change it to a little bit smaller, there will be 73. And it will also be shown in the map process, like the recipe name, the calories, and we got the found recipe and count 1. So it allows users to choose a calories range. We then search our partition's calories, compare with the range, and pick those within the range. We then combine lists from different partitions and calculate the number of recipes with calories within the range users want. And here we got this range, and we got 73 recipes within this range. It can help users to get an idea of like what kind of food is good for adult eating, because maybe like contain very, very small calories, but there's a lot of food may be unhealthy because they like contain really big amount of calories. And the third function is not like MapReduce one. It's a simple research function which takes the name of a certain ingredient and shows the calories contained in the measurement of per 100 milliliter grams or per ounce. We actually do this function in order to explore something maybe useful and interesting from our database, not really like count recipes, but like produce something maybe more useful for our users to get an idea of how many calories is inside one ingredient. So like if we type in apple, we'll get the 2 different datas, which is in 100 milliliter or grams, which is another one is ounce. So, and if we type in banana, it will be different. Yeah, the corresponding calories it contains. And it also deals with like wrong typing conditions. If we type in something random, it will show that, sorry, we cannot find the ingredient, so that user can try a different one, which may be inside our dataset, and we can get a result of it. So that's pretty much what we want to say about our project. And thank you very much for watching our video.
Thank you.